Hi viewers, welcome to Electric Funda. In this video lecture, we are going to discuss about mesh analysis and super mesh analysis, which is a basic electrical engineering topic. So, what is a mesh analysis? Mesh analysis is another systematic method for analyzing the circuits. It's purely based on the Kirchhoff's voltage law and Ohm's law. So, in which we find the mesh currents of each loop. Later, we will find with the use of those, we will find out power drops in each circuit, voltage drops in each circuit. So what is the difference between a mesh and a loop? So see that figure has six loops. And recall that a loop is in any closed path in a circuit. A mesh is a loop that does not contain any other loop within it. So like that, three meshes it has there. Mesh currents versus branch currents. A mesh current is a current that we imagine to travel around a mesh. We can imagine them to travel in either direction, but most people assume clockwise direction. A branch current is a current that passes through a branch. So in this assignment, we used small lowercase letters for uh, mentioning the mesh currents, uppercase letters for branch currents. Let's consider an example here. Uh, Capital I1, I2, I3 are the branch currents, small I1 and I2 are the loop currents. This circuit has two loops. Uh, so it has some steps to follow to simply identify the analysis and find the currents in through two branches. In the circuit, the mesh currents are labeled as small I1 and small I2, and the capital I1, I2, I3 are the branch currents. Given a circuit, what are the steps we have uh, to find the circuit mesh currents? Given a circuit with n number of meshes without current sources, so simply you have to follow these steps. So first we have to assign the mesh currents as I1, I2, I3 and so on, In for n number of meshes. Later we have to apply KVL for each mesh with the use of Ohm's law, and later we have to solve those n number of simultaneous equations for knowing for finding the unknown mesh currents. So see that figure. Um, Step 1 is assign mesh currents I1 and I2 in clockwise direction. Here step 2, apply KVL to mesh 1. So you start from a voltage source here from this point. Here we are getting a negative sign first, so minus 15, this one. Here this is I1, this is 5 ohms, so 5 I1 is the voltage drop here, plus 10 into I1 is in downward direction and I2 is in upward direction here, so you will take I1 minus I2, 10 into I1 minus I2 and plus 10 volts equal to 0. This is the mesh equation for loop 1, and for loop 2 apply KVL again along with the Ohm's law. Start from here, minus 10 plus 10 into I2 is in upward direction here and I1 is in downward direction. We are working on second loop, hence we have to take that current is more than I1. So then you have to take 10 into I2 minus I1 plus 6I1 plus 4I2 equal to 6I2 plus 4I2 equal to 0. Uh, After solving those equations to 15I1 minus 10I2 equal to 5 and 10I1 minus 20I2 equal to minus 10. So you have to solve those two equations to get the answers. Simply use Cramer's rule or matrix rules, some inversion rules like that, or else simply you have to go for a calculator for solving them. So simply we will get the I1 and I2 values. So if you get the I1 and I2 values, simply we will find voltage across any branch or power loss in any branch. For extending the analysis, once again we'll see here, mesh analysis has given us the values of the mesh currents I1 and I2. We can find all other currents and voltages in the circuit once we know these mesh currents. So simply if you know the I1 and I2 values, simply we will find that I3 value. That is the mesh analysis. So let you consider another example here. For mesh 1, the loop current is assumed as I1, and for mesh 2 it is assumed as I2. For mesh 1 we are applying KVL, then we'll get you start from 4 here, 4I1 plus 6 into I1 minus I2 plus 2 minus 10 equal to 0. After sending this one to that RHS side, it will becomes 4I1 plus 6I1 minus I2 plus 2 equal to 10 volts. For loop 2, 6 into I2 minus 7. Here the concept is important, whether you have to take I2 minus I1 or I1 minus I2. You have to consider I2 minus I1 when you are writing the mesh equation for loop 2, and you have to write I1 minus I2 when you are writing the equation mesh loop 1. So 6 into I2 minus 7 plus 2I2 plus 7I2 minus 20 minus 2 equal to 0. If you solve these two equations by using a KV calculator or any mathematical rules, simply will get the I1 and I2 values. Later it will be used for the circuit reductions. Steps in performing a mesh analysis on a circuit with no current sources. So already we discussed about without current sources only. Um, Simply assign mesh currents, apply KVL for each loop along with the Ohm's law and solve these equations. So if it has a current sources, then it is called as a supermesh analysis. So there are two types of supermesh analysis. So this is a case 1, a current source located in only mesh 1. So here in loop 2 we mentioned the mesh current is I2, but here this loop has a 5 amperes current source. This current source and this loop current both are in opposite direction. It is taken as a mesh super mesh current, and I2 is directly taken as a minus 5 amperes. So for loop 1 we will write the equation as a minus 10 plus 4 I1 plus 6 into I1 minus I2 equal to 0, and here we will submit I2 equal to minus 5 amperes. Simply we will get only one equation and we will get the I1 value. A current source shared by two meshes here. This is another case. This is also called as a super mesh, case 2. A current source shared by two meshes here. To handle it, we create a super mesh. Um, as here simply uh, assign the mesh currents first. This is for loop 1 I1 and for loop 2 I2. Um, the resultant current in this branch, 6 amperes branch, is I1 minus I2 equal to 6 amperes, or I2 minus I1 equal to 6 amperes, because we have to consider I2 minus I1 than I1 minus I2. Why? Because I2 is in the direction of 6 amperes, I1 is opposite to the 6 amperes. So supermesh equation is I2 minus I1 equal to 6 amperes. Uh, After writing the supermesh equation, simply remove this branch 6 amperes and 2 ohms branch, and apply KVL to the below loop. Minus 20 plus 6I1 plus 10I2 plus 4I2 equal to 0. So after solving these two equations, the first equation is I2 minus I1 equal to 6 amperes, and second loop equation is minus 20 plus 6I1 plus 10I2 plus 4I2 equal to 0. Then we will get the answers. These two are the KVL equations. We have to solve them. So when you have to recommend nodal analysis or a mesh analysis, so to use nodal analysis for circuits with fewer nodes than meshes, we will recommend a mesh analysis if the number of meshes are lesser than the nodes. Thank you.